What's up, YouTube? Today I'm going to show you how to build one of these, your very own custom LED acrylic sign. You can make these both for yourself or they make great gifts for friends. And the best part about this project is it's very simple to build and it's also extremely cheap. So let's get to it. So let's talk about the cost of this project quickly. This acrylic sign, I think I bought this acrylic for $7 a square foot. And I got multiple signs out of that, so that's obviously, $2-3 at most. The pieces of wood, I just used some old pieces lying around, and then I stained them with some stain I had lying around, so that was pretty much free for me. Some of the components I actually did have to buy were the LEDs and the resistors. But on a major electronics company, you can buy these for cents. They're super cheap. And finally, for my power supply, I just used an old phone charger. Free. So all in all, I spent less than $10 on this sign. So let's talk about the basic components you'll need for this project. The first major one is the sign. Now the sign is just a piece of acrylic that's finely engraved on the backside. What I did, although there's many different ways to do this, is I pulled a picture into a CAD program, traced the lines that I wanted, created a DXF file, and then uploaded it to a CNC machine. Then what I did was, on the back side of this piece, very finely etched, I almost can't even feel it, I just set the depth of the CNC machine to just barely take off any material. But then, what happens when you light it from the bottom with LEDs is all those imperfections show up, and that's what gives you your sign. The second piece you'll need is the base. The base is pretty simple. It just consists of two pieces, the top and the bottom. What I did is I hollowed out the bottom piece and then screwed it to the top piece. Then I added some rubber feet on the bottom just so it doesn't slide around when it's standing up. The other thing you'll need to do is in the top piece you'll need to create a notch. This notch is where the actual sign will sit. And then you'll also need to put holes in line with this notch, which I know are difficult to see in this video. But that's where your LEDs will actually sit and light up your sign. The third and final piece you'll need is your lighting system, which is basically going to consist of your LEDs, current limiting resistors, and then a power supply. And I'll show you how to design this so that you can make sure you don't blow up your LEDs. Alright, so let's talk through finding LEDs for your project. So right now I'm on mouser.com and I've already searched for standard LEDs through hole. So I know for this project we want something that's fairly bright. The luminous intensity right here is basically what we want. Now I think you might be able to go a little lower than what I've chose, but for my project I actually ended up using something that had 17,000 millicandela. And then I also went with a white color. So if I set those two filters like that, hit apply. One remaining, that's going to narrow it down to the one I want. So as soon as this loads here, there we go. And that's the LED that I actually ended up using. So if you pull up the data sheet for this product, it's right here. Now there's two numbers that we're going to need from this to carry out our calculations. And that's the forward voltage drop and then the typical forward current. So if you scroll through here, this is the dimensions. This is absolute maximum ratings. You don't want that. Electrical, optical characteristics. Here we go. Forward voltage, typical 3.3 volts, and then a forward current of 20 milliamps. So we're going to need to write down those two numbers, and they're going to come in when we're actually designing our LED circuit. Alright, so let's talk about actually designing this circuit. The program I'm using right now is MathCAD. I've talked about MathCAD in some of my other videos, and I'm actually making a series on it right now. But basically, we need to get a few values. So the battery charger that or the cell phone charger that I ended up using, most of these will have these numbers printed right on the front side of it. So if you just look at it, mine says the output voltage was 9 volts, and then the output current was 350 milliamps, and this is DC. And then if you remember our LEDs, the forward voltage drop was 3.3 volts, and then the forward operating current was 20 milliamps. So now let's talk about this picture. This is basically the circuit that you're going to be designing, where this is your power supply. And then what you have here are what I like to call these branches. Now in each branch there's a current limiting resistor and then a number of LEDs. And you can design this a bunch of different ways. I assume most of you know how to do this, but just in case you don't, I'll kind of run you through the calculations. Pretty much the max number of LEDs you can have in each branch, so in something like this, for the numbers that I have, is actually 2.727. And that's because with 9 volts, I can only put so many LEDs in line here and actually get them to line up. Now, I could probably get away with putting 3 LEDs in series here, but they might not be quite as bright as I'd like them to be. Also, I can only have so many branches because my power supply is only providing so much current. If you just take your 350 milliamps and divide it by the 20 milliamps, which are these two numbers right here, it tells you how many LED branches you can possibly have. So then I decided I want 2 LEDs per branch, 1 LED, 2 LED, and then basically this just calculates the remaining voltage that needs to be dropped out by the resistor, and then if you take that voltage divided by the current using Ohm's law, it tells you exactly how much your resistance needs to be. So if you just follow these formulas, that should calculate out your resistors for you. So I thought I might give you guys some advice on how you can make this project better or just make it more customizable. So the first thing that I would say that I wish I had done, but I didn't do because I didn't have the time when I was building this one, is I wish I would have put a switch somewhere on it so that I could turn it on and off without unplugging it from the wall. The next thing that I think would be really cool is what if you had some sort of button that you could toggle and it would switch the colors of the LEDs. Or, if you wanted to get really fancy, you could control this thing with a microcontroller and have it fade the colors from red to green to blue to pink to purple and back to red, or something like that. You could even have the LEDs grow brighter and dimmer. If you hook it up to a microcontroller, really the possibilities are endless, and that's why I think this is such a cool project.